morning students, welcome to my channel Miracles of Math. So today we are here to discuss what is logarithms. What are logarithms? Where are they useful? Logarithms are actually a different dimension of numbers. Like the numbers whatever we are discussing 1, 2, 3, 4. Okay. They are actually seen in some other dimension. For example, if you want to have the calculation of the distance between sun and the earth, it is some millions of kilometers. So whenever we are doing some problems related to that level values, it is very difficult for us to handle such a big numbers. So what actually logarithm does is to reduce that very large number to another dimension of a very small quantity, so that we actually solve that, and at the end, if at all we want, we will again convert that into the bigger dimension or whatever the dimension we actually prefer for. So what are these logarithms and what is the another dimension of representation of a number? Let us quickly see here. Let us say we have a number 2 cube and you know that which is equal to 8. So this is the normal representation. How do we represent the same in logarithms? This exponent or the index, okay, so that is 3, which will be equal to log LOG, we represent with LOG, log this base, okay, the final result, log 8 to the base, this base will come here, to the base 2. 2 cube equal to 8, the representation in logarithm is this exponent 3 is equal to log 8 to the base 2. Log 8 to the base 2. I'll give you one more example. 10 power 4 is equal to 10,000. 10 power 4 is equal to 10,000. So in logarithms, this 4 will be equal to log 10,000 to the base 10. See, in some new representation, in some new dimension, number 10,000 is actually equal to 4. In this logarithm, 10,000 is actually equal to 4. See, such a large number 10,000 came to a small number 4, where logarithm of 10,000 to the base 10. Okay, we'll take one more example. 10 power 15 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Such a large number is 10 power 15. But in logarithms, when you convert, 15 is equal to log of 1,0,0,0,0,0 15 times to the base 10. So this large number can be represented as 15 in terms of logarithms. When we use logarithm, we can convert that large number to just a small number 15. So in that way, logarithms will be useful to reduce a very big data to very small values, which will be convenient for us in calculations, and whenever we require, we will again convert that back to the actual numbers. So let us quickly have what is logarithm and what is the definition of that, which terms can come in logarithms and which terms cannot be dealt in logarithms. So if we have some number like this, a power x is equal to n, just like 2 cube is equal to 8, what we have discussed now, a power x equal to n. So this x will be equal to logarithm of n to the base a. So are there any restrictions for this log n to the base a, or can any number occupy this n and a? Logarithm is only defined for positive numbers. Logarithm is only defined for positive numbers. That means this n should always be greater than 0, not even equal to 0. N is always greater than 0. In the same way, the base, as n is positive, here a also should be positive. As n is positive, a also should be positive. So a also should be positive, and a cannot take the value 1. The base cannot take the value 1. Okay. So in logarithms, the restrictions we are having is logarithm is defined only for positive numbers. It is greater than 0. Base should also be a positive number greater than 0, and base should not be equal to 1. Base should not be equal to 1. Okay. So if at all we are having like this 2 power x equal to 8, we know x equal to 3. That's why saying we can know x equal to 3. So that x is equal to log 8 to the base 2. So using different laws, which we'll see in the next steps, log 8 to the base 2, we get it as 3. That is the answer for this one, 2 cube equal to 8. So if we have numbers like this, okay, log 64 to the base 2 is equal to 6. Convert this into normal representation. Convert this into normal representation. So this base will be the base, and this number will be its exponent, that is the index. 2 power 6 is equal to that number. So 2 power 6 is equal to 64. Is that correct? Let us see some more examples on how to convert logarithm form in normal form and normal form to logarithm form, and then we'll see some more laws, some more properties of logarithm. Log 27 to the base 3 is equal to 3. Log 27 to the base 3 equal to 3. How do we represent this in the normal form? This is the base. The base will be here. 3 power this number 3 cube is equal to the actual number 27. Yes, so 3 cube is equal to 27. What if the number is given in this format? Okay, 4 power x is equal to 64. 4 power x is equal to 64. How to convert that into logarithm? This x is equal to log of 64 to the base 4. Log of 64 to the base 4. Clear? So let us quickly see some properties on logarithms. Log of xy, x into y. Log of x into y till some base a. Okay, that means we want to find logarithm of product of two numbers, 10 into 20, 30 into 40, whatever the numbers are. Okay, so this is actually equal to sum of individual logarithms. You should be very careful here. It is actually sum of individual logarithms. Many of you in many cases you mistake this formula with log x plus y is equal to log x into log y. Product is equal to sum, but not sum is equal to product. This is wrong. Okay, always remember the product will be equal to sum. Product equal to sum. Let us see how this formula was obtained. Let us take this as some m, and let us take this as some n. Okay, let log x to the base a is equal to m. So this one, when you change into normal form, a power m, this base will come a power m is equal to x. A power m is equal to x. In the same way, let us take this one as n. Let log y to the base a is equal to n. So which represents a power n is equal to y. A power n is equal to y. Okay. So now see here, what we want here, log of x into y. Let us multiply these two. So when you multiply these two, x into y is equal to a power m into a power n. A power m into a power n, that is actually a power m plus n. Correct? In indices we have seen that. So xy is equal to a power m plus n. Now apply logarithm for that, or convert this into logarithm format. Okay. So this is equal to m plus n equal to m plus n is equal to log xy to the base a. Log xy to the base a. So what is m plus n? M plus n is this one. So m plus n is actually equal to log of xy. This is the proof of how we obtain this formula. In the same way, there are few more properties which we will not solve here, which we will not try to prove, but all the proofs, all the laws, or all the properties are actually as basic as this one. You can take one as m, one as n. From there, you just do, you will get that proof. Alright. So the next formula we will be talking about Now see, product is equal to individual sum. What about the division of this one? Log x by y to the base a. If at all we want to discuss about the division, quotient. Okay. So this one you'll get as log x to the base a minus log y to the base a. Division is actually difference. How? You take the same proof as we have done earlier. Take this as m, take this as n, and you know one thing, a power m by a power n is equal to a power m minus n. So based on this formula, we actually get this one. So please try to do that proof. Okay. So we'll discuss some more properties. Logarithm of a to the base a, that means log 9 to the base 9, log 100 to the base 100, log 10,000 to the base 10,000, whatever it is, if these two numbers are same, what happens? Let us think this value is x. So when you convert this in normal form, what happens? A power x is equal to a. A power x is equal to a. So this is x power a power 1. So when you equate these two, as the bases are equal, the exponent should be equal. So it is x is equal to 1. Yes. So log a to the base a is always equal to 1. Log a to the base a is equal to 1. Log 5 to the base 5, 1. Log 10 to the base 10, 1. Log 100 to the base 100 is 1. Whenever these two values are equal, the value is equal to 1. Next one. Log x power m to the base c. Log x power m. Okay. This is actually equal to log of, if you remember, x power m is x into x into x into so on, how many times? M times. And using the first rule, xy, you can actually sum individually. You can individually add them. Log x to the base a plus log y to the base a. In the same way, log x plus log x plus log x plus log x, how many times? M times you are adding. Just like 2 times here, you are actually adding m times. So this is equal to m times of log x to the base a. M times of log x to the base a. See, this m will come here. This m will come here. Understood? These are few properties. I will give you some more example for this one if you want. Let us say log 3 power 4 to the base 2. Okay, so this 4 will come here, which will be equal to 4 times of log 3 to the base 2. 4 times of log 3 to the base 2. So depending on the question, depending on the applications, we will be using all those. Alright, so let us see few more properties in logarithms. Log 1, whatever number it is, okay. The next property is log 1 to the base a. We need to find what is the value of this one. Let us take it is equal to x. So a power x is equal to 1. So a power x is equal to 1, I'll write it as a power 0. So as bases are equal, exponent should be equal. So x is equal to 0. So log 1 to the base a, always to any base, it can be number 2, 3, 4, 5, whatever number it is. So log 1 to the base a is always equal to 0. Okay. Next one. Log x to the base a power n, let us say. We are having a power here. Okay. So this n will come here and becomes 1 by n. This n will become 1 by n. So it is 1 by n times log x to the base a. A simple example, log 5 to the base 2 power 1 by 2. So let us say you are having such type of formula. So this 1 by 2 will come here and becomes 1 by n. 1 by n. N is 1 by 2. 1 by 2 into log 5 to the base 2. So it is actually 2 into log 5 to the base 2. Log 5 to the base 2. Understood these properties. Don't worry, we will discuss more examples going on through. But let us first have some grip on the properties, and then we can, so that we can apply those properties in the problems. Log m to the base n. Let us say we are having log m to the base n. This one we can split into two different logarithms. We can split this into two different logarithms. How? See here. Log m by log n. We can write this as log m by log n. And there is no base. Base is n here, but here there is no base. To any base. To any base. A can be anything. But a should not be 1, a should not be negative. A can be anything else. So this one we can actually divide this into 2. Log m to the base a, log n to the base a. Log 5 to the base 3. Okay. So depending on the problem, whenever we want some applications, we can write this as log 5 by log 3 to any base. Okay, let us say some base 7. 7, 8, 9, whatever base you want you can take. But this can be divided, split into two parts with 5 and 3 here, and base can be anything. Base can be anything. One more property. A power log n to the base a. A power, and this complete logarithm is in exponents. This complete logarithm is in exponent in the index. Okay. So whenever we have such type of thing, when these two are equal, the number itself, the n will be its answer. N will be its answer. The proofs of all these are available everywhere in all the textbooks. Okay, we are not going to spend time on all proving all those. So 3 power log 5 to the base 3. Before all we are having some number like this. Okay, so this 3 and this 3 are equal, so the answer is 5. Answer is 5. How we get this one? Let us take this as x. We don't know what is the answer. Okay. So when you convert this, treat this as some t. Okay, this has some t. So let us say we are having 3 power t equal to x. Convert this into logarithm. We will have t is equal to log x to the base 3. T is equal to log x to the base 3. And what is t? T is this one. This one we assumed as t. So this is equal to log 5 to the base 3. So when you compare these two, as 3 and 3 are equal, x should be equal to 5. So this x is nothing but it is equal to 5, which is nothing but this number. When these two are equal, you can directly write as 5. Okay, and one more property, which is actually clubbing of two different properties earlier. Log a power x to b power y, let us say. Log a power x to the base b power y. So this x, I said, this will come here. So x into log a, and this y will move here and becomes 1 by y. Okay, so that becomes x by y and log base b. Log a to the base b. So these are the different properties which should be there in your mind. For sure, without that we cannot do majority of the problems. Only a few we can do without these properties, but 99% of all the problems in logarithms are linked with one or the other property. Let us see some examples. Find x if log x to the base 9, log x to the base 9 is equal to 2.5. Is equal to 2.5. So we want to find the value of x such that this value is equal to 2.5. Okay. So converting this into the normal form, what is that? 9 power 2.5. 9 power 2.5 is equal to x. Can we leave like this? No. We want to find the value. 9 power 2.5. So 9 is 3 square. 3 square whole power 2.5 is 5 by 2. So that is the value of x. So this is equal to 3 power 2 into 5 by 2. So these two gets cancelled and it is 3 power 5. Whatever the answer is for. So that gives you the value of x. X is equal to 3 power 5. Let us see some more problems. Log x to the base 3 is equal to a. log x to the base 3 is equal to a. Then find the value of 81 power a minus 1. 81 power a minus 1. Okay, so this is what given. So convert this into the normal form. What you'll get? You'll get x is equal to, you'll get 3 power a. 3 power a is equal to x. Yes, 3 power a is equal to x. We can use this result here. How? See, 81 I can write as 3 power 4. 81 we can write as 3 power 4. 3 power 4 whole power a minus 1. 3 power 4 whole power a minus 1. So it is 3 power 4a by 3 power 4a by 3 power 4. Is that correct? If you are confused, I will write it again in this way. So it is 3 power 4 power a by 3 power 4 power 1. Yes, a power m minus n is a power m by a power n. So this is 3 power 4 power a means it is actually 3 power 4a, or I can write it as 3 power a whole power 4. You can write that one a power m whole power n, which is also equal to a power n whole power m. Okay, so with that it is 3 power a whole power 4 by 3 power 4. So what is 3 power a? 3 power a whole power 4 is 3 power a is x. So this, the value will be x power 4 by 3 power 4. The value of that will be x power 4 by 3 power 4. What is 3 power 4? 3 power 4, 3 into 3 into 3 into 3. 3 3 is 9, 9 3 is 27, 27 3 are 81. 3 power 4 is 81. Let us quickly have few more problems on logarithms. Now the question is splitting of a number to different logarithms. Splitting, that means if at all there is a number like log 8. Log 8, let us say. Okay, I can write this as log 2 into 4. People sometimes we doesn't represent the base, which means that it is true for any base. Okay, generally whenever the base is not mentioned, we take it as 10. We take the base as 10. So this one we'll write as, we can write as log xy is actually equal to log x plus log y. So one logarithm can be split into 2 or any number of things. Okay, log 12 let us say. So I'll write as log 3 into 4. So I'll write as log 3 plus log 4. Log 3 plus log 4. All these conversions are important in the upcoming problems. Okay, log 1 plus 2 plus 3. Log 1 plus 2 plus 3. What is 1 plus 2 plus 3? It is actually log of 6. When you want to split this into different things, see, it is log of 6. I can write as 1 into 2 into 3. I can write 1 into 2 into 3. So it is log 1 plus log 2 plus log 3. This is one of the important things, because log of 1 plus 2 plus 3 you finally got as log 1 plus log 2 plus log 3. This is not true for all the numbers. For this case it is valid because 1 plus 2 plus 3 is 6, as well as 1 into 2 into 3 is also 6. So that's the reason for this formula, for this problem especially it is true, but not for all the problems. So now expansions will be given and we need to compress that into one single term. We need to compress that into one single term. This is very important. Log 12 minus log 3 minus log 4. We need to represent this as one single number. How? See, this is actually log 12 minus log 3 plus log 4. Leave this as it is, log 12 minus log a plus log b. It is actually equal to product of 3 into 4. Using the first property, if you remember, this is actually log 3 into 4. So it is log 12 minus, it is again log 12. Log 12 minus log 12 is 0. The answer of this one is 0. I will do the same thing in another way. See here. a power m minus, see, log xy, you know that log xy is equal to log x plus log y. Very good. But when do we get a negative? We get a negative something like log x minus log y when we have a division here. When we have a division here, x by y. In the same way, as we have a negative, we can say this is actually equal to log 12 by 3. So, treating only these two, I can say it as log of 12 by 3 minus log 4. Correct? Even the same 4 can also be clubbed here only with, as it is negative, it comes to denominator again. Log x minus log y is log x by y, x by y. So, seeing here only, with this step only, we can write in one single step like this. It is equal to log of 12 divided by, why divided by? Because we have a negative here. Here also we have negative here. So, these two will come in the denominator. As many negatives as there will come in the denominator. As many positives are there, all those comes in numerator. So, this is log 12 by 12, which is equal to 1 log 1, and log 1 is actually equal to 0. The same thing which you got earlier, log 1 is 0. Okay, let us see some more questions. 1 by 2 log 9, 1 by 2 log 9 plus 1 by 4 log 81, 1 by 4 log 81 plus 2 log 6, 2 log 6 minus log 12, minus log 12. So, finally, we need to bring this one into one single term. Let us see. 1 by 2 is here. I will write 9 as 3 square. 1 by 2 into log 9 as 3 square. And I said you before, log a power m is actually m. This m will come here. Okay, that exponent will come here. In the next step, we'll do that. Plus 1 by 4 into log 81, I'll write as 3 power 4. 3 power 4, just now I said you before. 3 power 4 is 81. Plus, for now, leave it as it is, 2 log 6 minus log 12. We'll see at the end what happens with this one. Okay. So, in the next step, this 2 comes here. 2 by 2. This 2 comes here. 2 by 2 becomes 1. So, it is log 3. Plus, this 4 will come here. 4 by 4 is again 1. So, it is log 3 again. Plus 2 times of log 6. 2 times, okay, leave it like this, we'll come to the next, in the next step, 2 log 6, or what I'll do, I will take this 2 and I will keep square here. Yes or no? In the whatever it is, this 2 will come here in the next step, if at all we want to convert it again. But 2 log 6, I can write as log 6 square minus log 12. Minus log 12. See here, log 3 plus log 3 is 2 log 3. 2 log 3, or I will write this 2 here, so that becomes log 3 square, which is actually equal to log 9, okay, plus log 36 minus log 12. So, see here, it is log 3 square log 9 plus log 36 minus log 12. So, it is log of, as these two are addition, you can multiply them 9 into 36 by, as is a negative, it comes in the denominator. So, 12 ones and 12 threes. So, 9 threes are 27. So, this value, the given question, came to one single step, that is log of 27. Once again, see here. 9 I am writing as 3 square, that 2 will come here, these 2 gets cancelled and becomes 1, becomes log 3. 81 I am writing as 3 power 4, this 4 will come here, gets cancelled and only log 3 is left. 2 log 6, I am taking this 2 here, it becomes 6 square log 36. and log 12 I'm remaining as it is. We are keeping as it is. So once you come to this step, as you have addition, these two will be multiplied 9 into 36, and as you have subtraction, it will be divided by 12. So from there you got the answer as log 27. Correct. Let us see one more. One minus 1 by 3 times of log 64. 1 minus 1 by 3 times of log 64. We need to express this as one single logarithm at the end. See, 1 is there. I said you, whenever there is no base, we can consider the base as 10. So there is no base, I am considering the base as 10. And 1, I will write it as log 10 to the base 10. I said you log a to the base a is 1. 5 to the base 5, 1. 100 to the base 100 is 1. In the same way, 10 to the base 10 is 1. Whenever there is no base is given, we represent, or we by default we take that base as 10. Minus this 1 by 3 I am sending it here, minus log 64 to the base 1 by 3, sorry, to the power 1 by 3 to the base 10. 64 I can write as 4 cube. 64 I can write as 4 cube. So log 10 to the base 10 minus log 4 cube power 1 by 3 to the base 10. So these two can be cancelled. So you are left with log 10 to the base 10 minus log 4 to the base 10. Log x minus log y is actually equal to log of x by y. 10 by 4 to the base 10. So if you cancel with 2, you will have log 5 by 2 to the base 10. So the answer for this one is actually equal to log 5 by 2. The value of this one in one single logarithm is log 5 by 2. Once again, what we have done here, 1 I am writing it as log 10 to the base 10, and 64 I am writing as 4 cube. So finally we have this term log 10 to the base 10 minus log 4 to the base 10. Now as these two are minus, we can just divide them. People, you can do this one only when the bases are equal. All logarithmic applications, whatever we discussed, all the laws are possible only when they are to the same base. If they are to different base, we shouldn't do all those laws. We cannot apply. We need to convert in some or the other way, and then only we can apply all the rules. Let us see some more examples. Log x minus log x minus 1. Log x minus log x minus 1 is equal to log 3. So find value of x. Log x minus log of x minus 1 is equal to log 3. Find the value of x. So log x minus log y, it is log x by y. Log x by y. So it is log of x by x minus 1 is equal to log 3. So when you compare these two, what happens? X by x minus 1 is equal to 3. There is no base given, that means we can say these two are to the same base 10. Whenever there is no base given, we can conclude that these are to the base 10, 10, 10. So as all those are the same base, we can directly equate these two. So cross multiply, x is equal to 3x minus 3. So bring this x this side and 3 here. So 3 is equal to 3x minus x is 2x, and x is equal to 3 by 2. You will get the answer x is equal to 3 by 2. Simple. Log a minus log b, log a by b. So you got the answer as 3 by 2. Yes, that is correct. Let us solve one more very good question. Alright, so this is the question, and one more property which I missed before. So let us see what is this. Log a to the base b. Log a to the base b. I told you this is equal to log a to some other base c by log b to some other base c. We can write like this. What I will do, I will write this one as 1 by log b to the base c by log a to the base c. This log a I am bringing it to the denominator. So this one is equal to 1 by c log b by log a. I can write it as log b to the base a. The same property. Log b to the base a by log a to the base a. I'm writing as log b to the base a. So see here. These two are actually reciprocal of one another. These two are reciprocal of one another. That means I'll write once again log 3 to the base 2 is equal to 1 by log 2 to the base 3. So these two, if at all we are interchanging, even the numbers will be reciprocal to one another. Log a to the base b is equal to 1 by log b to the base a. You can ask me, sir, why do we need all these properties? These are useful to solve different problems, just like this one. So what we'll do, 81 we know it is 3 power 4. 81 is 3 power 4. So this is 3 power 4 into just the property which we use now, log 3 to the base 5 by 1 by, I will write this as log 5 to the base 3. I will write as log 5 to the base 3. This is actually the reciprocal of this one, when you can interchange these two. Plus 27 is 3 cube. Okay, so 3 cube power 3 power into log 36, I will write as 6 square. I will write as 6 square to the base 9. 9 I will write as 3 square. Understood? This is 6 square, this is 3 square. Plus 3 power 4 into log 9 to the base 7. I am writing it as log 7 to the base 9. 1 by that one, I am actually reciprocating it and I am changing these two. Log 7 to the base 9. So this 4, carefully check, I am not writing the next step. Please listen properly. This 4, I am writing it as here. This 4, I am writing it as 5 power 4. Why I can write? Yes, this 4 will come here. It can be here, it can be here. No problem. That is the property we discussed. So this is 3, this is 3. As these two are equal, this number only will be left. Remember, a power log n to the base a. When these two are equal, the answer is n. We discussed this one. So answer is 5 power 4. Plus, see, 3 power 3 into this 2 will come here. 2 into log 6. And this 2 will come and become 1 by 2. This 2 in the base. Remember, log n to the base a power n. Okay. So this n will come here and becomes 1 by n. 1 by n into log n to the base a. Yes or no? So same application. This 2 will come here and this 2 becomes 1 by 2 into log 6. Plus 3 into this 4, I am writing it as here. 3 into log 7 power 4 to the base 9. Or 9, what I will do, I will write as 3 square. I will write as 3 square. Okay, we'll do in this step only so that we can reduce one step. This 9, I am writing it as 3 square. This 2 will come here, becomes 4 by 2. 3 power 4 by 2 becomes 2. 2 log 7 to the base 3. Correct. And this 2 I am sending here. This 2 I am sending here, 7 square. So it is 5 power 4, 5, 5, 25, 25, 25, 625. Plus these 2 gets cancelled. This 3 will go here. So it becomes 3 power, base is 3 here, I forgot. 3 power, these 2 are cancelled. This 3 I am taking it here. Log 6 cube to the base 3. Plus this is this, as these two are equal, so it is equal to 7 square, that is 49. So this is 625 plus this is 6 cube. Okay, as these two are equal now, it is equal to 6 cube, that is 216 I guess, plus 49. So whatever it is, you please solve for that answer. 625 plus 6, that is 6, 216, and that is 49. So 9, 6, 15, 15 plus 15, 20, 4, 5, 6, 7, 8, 9, and 6, 7, 8, 890. Your answer, if I'm not wrong, if my calculation is correct, should be 890. See how confusing question is that. But when you apply the laws or the properties step by step together, so you will get the answer. Never ever leave the mathematics question in between. Definitely you will get that at the end if at all you are doing in the right way. Let us see some more properties. Log 1 is 0. Log 10 to the base 10 is 1. Log 100 to the base 10, can you tell me? 100 is actually 10 square. 100 is actually 10 square. So log 10 square to the base 10. So this 2 will come here. So it is 2 times of log 10 to the base 10. That is again equal to 1. So log 100 to the base 10 is 2. Log 1000 or 10 cube to the base 10. It is simply this 3 will come here. It is 3. Log 10 power 5 to the base 10. It is 5. Log 10 power minus 4 to the base 10. It is minus 4. Yes, you can get negative numbers here. Negative should not be there inside the logarithm. Your answer can be positive, can be 0, can be negative, whatever it is. So this is some introduction on logarithms, on properties and how to use those applications. So next lecture will be about how to find logarithms and anti-logarithms using log and anti-log tables. If you want to find the value of log 99.5, you don't have any property to use. 99.5, 67.2. How do we do that? So for that, logarithm tables are given and anti-log tables are also given. The reverse of logarithm is anti-log. So in the next lecture, we'll be seeing how to use logarithm table and anti-logarithm table to find the values. Okay. So this information is there with you. Please try to solve few examples, few more questions. And if you want more problems, please comment in the comment section so that I can make one more video on problems on logarithms. Thank you.